Hello, my name is Mubashir Jamal, and my groupmate's name is Umair Muhiddin. Today we'll be talking about industrial control networks. We'll begin with a table of contents. We'll start off with a brief introduction and then move on to a slight overview. Then we'll review the different underlying technologies and the different areas of application. We'll then move on to the different pros and cons, the future trend, and a slight conclusion. Introduction. The phrase industrial control network refers to many types of control systems and related instruments, which consists of devices, systems, networks, and controls needed to operate and or automate industrial processes. Is basically a system of networked equipment that they use to control actual physical equipment in many different industrial contexts. This is what is known as industrial control network.
Overview. So the industrial network systems mainly deal with large-scale data transport. They allow us to connect to devices in difficult locations through the use of routers, switches, Ethernet, and power cables. They use quality-built and rigorously tested networking equipment, which helps the industry workers communicate by sending large amounts of data simultaneously by using the different networking solutions provided by the companies. In the industry network, there are several networking solutions, from which we will be discussing the three main ones: the Ethernet, Fieldbus, and wireless. The main purpose of the industry network control systems is to offer automation, efficiency, and reliability for the facility workers and the systems, and allow them to have a safe yet productive working environment where they are able to effectively manage their machines and systems. The industrial network systems cover a large domain and are big contributors to fields such as um, automation, manufacturing, and electricity generation. They make use of a variety of protocols like Ethernet IP, EtherCAT, Profinet. These are protocols designed by different companies to achieve benefits like low latency and efficient peer-to-peer connections. Um, these protocols basically help the systems and the machines fulfill their rigorous requirements. They also cater real-time needs and a large number of systems. So what that basically means is that the input data is processed within milliseconds so that it is available virtually immediately as feedback to the process from which it is coming, allowing for the processes and systems to work smoothly. So the first type of industrial network system is the fieldbus. The fieldbus is basically a name of a family of industrial networks used for real-time distributed control and are standardized by the International Electrotechnical Commission. Fieldbus is an industrial network system for real-time distributed control. It is a way to connect instruments in a manufacturing plant and works on a network structure which typically allows star, ring, branch, and tree network topologies. Previously, computers were connected using RS-232 serial connections by which only two devices could communicate, which required that each device have its own communication point at the control level, while the fieldbus is the equivalent of the current LAN type connections, which require only one communication point at the controller level and allow multiple, usually hundreds of analog and digital points to be connected at the same time. This reduces both the length of the cable and the number of cables required. Furthermore, since devices that communicate through fieldbus require a microprocessor, multiple points are typically provided by the same device. The fieldbus are typically structured in hierarchical levels as distributed control system. In this hierarchy, the upper levels for production management are linked to the direct control level of programmable logic controllers via a non-time critical communication system, for example, the Ethernet. The fieldbus links the programmable logic controllers of the direct control level of the components in the plant of the field level, such as sensors, actuators, electric motors, consoles, lights, switches, valves, contactors, and replaces the direct connections via current loops for digital input and output signals. The requirement for a fuel bus are therefore time critical and cost sensitive. Since the new millennium, a number of fuel buses based on real-time Ethernet have been established, and these have the potential to replace traditional fuel buses in the long term. So the next industry network system we're looking at is the Ethernet. The industrial Ethernet is the use of Ethernet in an industrial environment with protocols that provide determinism and real-time control. Protocols for industrial Ethernet include EtherCAT, Ethernet IP, which is a common industry protocol that adapts to the Ethernet, Profinet, which is an industry technical standard for data communication and specially designed for collecting data of controlling equipment under tight time restraints. There's also others like PowerLink, Circos 3, CC-Link IE, and Modbus TCP. Many industrial Ethernet protocols use a modified media access control layer to provide low latency and determinism. Some microcontrollers, such as the Satara processor, provide industrial Ethernet support. Industrial Ethernet can also refer to the use of standard Ethernet protocols with rugged connectors and extended temperature switches in an industrial environment for mainly automation or process control. Components used in plant process areas must be designed to work in harsh environments of extreme temperatures, humidity, and vibration that exceed the ranges for information technology equipment intended for installation in controlled environments. Also, the use of fiber optic Ethernet variants reduces the problems of electric noise and provides electric isolation. Some advantages of using the industrial Ethernet is increased speed from 9.6 kilobytes per second with the RS-232 to 1 gigabytes per second with the gigabit Ethernet. The other advantage is option to use ubiquitous Cat5 and Cat6 cables, option to use optical fiber to increased distance, ability to use standard networking hardware for wired and wireless communication, ability to have more than 2 nodes on link, which was possible with the RS-485 cable but not with RS-232. And there's also better interoperability and the potential to use peer-to-peer architectures as opposed to the client-server ones.
Underlying technology. Initially, manufacturing and processing plants were controlled mechanically, either manually or using hydraulic controls. Mechanical control systems were replaced by electronic control loops that used transducers, relays, and hardwired control circuits. As discrete electronics are things like transistors, resistors, and things like capacitors, right? They became more prevalent. These systems were enormous, took up a lot of area, frequently needing like kilometers of wiring, both to the field and to connect to control circuits. And the functionality of many of these analog control loops that could be reproduced by a single digital controller, thanks to the introduction of integrated circuits and microprocessors. Eventually, digital controllers replaced the analog controls. This has resulted in a networking environment that looks the same on the outside, but however, fundamentally have much different requirements. Areas of application. Machines and equipment are all increasing in intelligence and require more and faster internet connectivity. Therefore, they require high standards of critical automation and control. Some of these industries are the manufacturing industry, for example, like industries that make electrical equipment, different appliances, components of different things, anything that manufactures, right? Another thing is high operating temperatures. So anywhere where the temperature is really high, for example, industrial distillation or concentrating things, this, like the temperature there is approximately 320 degrees max, right? It's really hot, so automation is required there. Machine vibration. Machine vibration is pretty self-explanatory. When the machine vibrates when it's not supposed to, right? This is usually when there's a problem within it. Power/voltage fluctuations, robotic warehouse systems. Another example is electromagnetic interference. These are things that require any sort of radio frequency, right? For example, your microwave requires that.
Pros and cons. So some of the pros are that industrial network systems increase the health and safety of the workers there. The primary benefit for industrial control systems in general is health and safety. So being able to understand the environment in which the workers are being dispatched to or entering can give you the critical advantage in keeping them safe. For example, if there's a mining environment, sensors can relay information across the DMR Tier 3 network that can report if the mine is stable or if there are harmful chemicals in the air. With this information, the correct and safe course of action can be taken from there. The second advantage is that they provide good, robust equipment, which is able to withstand harsh temperatures and conditions, and they also require minimum maintenance because the equipments are made of good quality. The third advantage is that there's a minimization of threat and exposure. So, for example, when a power line goes down, an industrial control system can detect this, particularly if there's a monitor that can alert control that a pole is down or a line is actually touching the ground. Not only can workers be warned about this, but the fault area can be remotely isolated and turned off to protect the people around it. This includes workers as well as the public in general when there's a failure or fault. Another advantage is that the processing and control can be on the fly. So it can be done without being on the actual site through wireless and the different internet connections, the network connections with the machines. The another advantage is that the diagnostics from devices can solve problems before they become critical. And the last and the most important advantage is that there's the protection of assets. Since protecting assets it can be protected through prevention. So, for example, when a fault is identified, such as an over voltage condition, the exposure that the transformers downstream have, the transformers downstream have to over voltage. The over voltage can be minimized. Some transformers are multi-million-dollar assets, so in avoiding an over voltage condition, assets can be protected. In understanding the exposure a transformer has had to over voltage, you can get the same equivalent life cycle out of the asset through managing load or reducing the threshold of load if it has seen over voltage multiple times. So this can be a key function, and protecting the assets and optimizing them is a key function of all industrial control systems. So some of the disadvantages of having industrial network systems is that, number one, the vulnerabilities in the industry processes increase the risk of cyber attacks. The traditional industry network organizations weren't used to be that connected, and as they start getting more connected with more devices and equipment, the surface attack increases and more cyber attacks are targeted to industrial networks. The second advantage is that there's a lack of visibility and control in the industry control system networks. Most of the industrial companies struggle to have visibility over its resources and assets, which prevents them from having a complete control over the network and infrastructure, the equipment, and the material. The third disadvantage is that there's a bit of difficulty in controlling the control layer protocols. The typical industry networks include numerous devices, sensors, and gateways that potentially communicate using different protocols. And this creates a difficult to maintain network architecture. The last disadvantage is that the network performance and availability. As more devices are connected, the network will need more capacity, and the industrial network vulnerabilities can result in costly damages, mainly as a result of downtime of the network systems.
Future trends. Industrial networks encompass a wide range of applications, and these are becoming more and more important in industries such as manufacturing and power generation. As frequency of industrial networks grow, they become more and more integrated with traditional technologies, right? Such as the internet. This means a higher number of experts are required to interface with these industrial networks in some sort of way. Future industrial networks have plans to integrate much more wireless technologies, right? Such as 5G and LoRa. And there are much more technologies that want to support the idea of automation in the industry. They also want to show support by providing control, remote command, monitoring the sensors and actuators on the actual factory floor. According to a comprehensive research done by the Market Research Future, industrial control systems market has been estimated to reach a market size of 168 billion by the end of 2026 with a growth rate of 8%. These are very healthy figures and shows a future of the industrial control systems market. In conclusion, industrial control networks are a networked set of equipment that are used to operate actual physical equipment, right? There are three types of industrial network solutions, such as Ethernet, field bus, and wireless. It can also be utilized in a variety of applications. For example, the manufacturing sector, high temperature operations, and the electromagnetic interference, and much more as mentioned before. The industry is also shown to evolve and become much more wireless and automatic using different technologies like 5G and LoRa.